Hello and welcome to the UKMT Club and to this lesson on triangles. These lessons are aimed at students who would like to improve their score in maths competitions such as the UKMT Maths Challenges or similar competitions that require lateral thinking skills. I'm Dan and I'm 17 years old and currently in year 12. I've done the UK Maths Challenges every year since year 8 and have progressed to the Kangaroo and Olympiad rounds. The lessons will start by going over the fundamentals you need to know, and then I will go over certain questions from past papers and explain how to apply the techniques previously discussed. So let's get started with triangles. So I'm sure you all know that the angles in a triangle add up to 180 degrees, and I'm sure you also know the four main different types of triangles. They are the equilateral triangle, where all angles are 60 degrees and so all sides have the same length. The isosceles triangle, which have two equal angles and thus two equal sides. The right angle triangle, which, as its name suggests, has a right angle. And a scaling triangle, in which all the angles are unequal and so all the sides are of different length as well. However, there is also one more triangle that I feel comes up a lot in the UK Maths Challenge, and you need to be able to recognise it when it comes up. And that is half an equilateral triangle. So if I just quickly draw an equilateral triangle, so just like that. So just pretend this is an equilateral triangle. So all the angles are 60 degrees, and so to obtain half an equilateral triangle, all you have to do is divide the equilateral triangle in half via one of its axes of symmetry. So, for example, just like that. And so obviously this angle here will be 90 degrees, this angle here will be 60, and this angle here will be 30. So obviously one way of identifying a half an equilateral triangle is through its angles. However, one other way you need to be able to identify a half equilateral triangle is by the ratio of the sides. So if the hypotenuse, so this side here, is twice as long as the side opposite the 30-degree angle, so in this case it would be this side. So if the length of this side here is double the length of this side, then you know that the triangle is half an equilateral triangle. So the next thing I would like to talk about is the exterior angle rule. And so this rule it's not necessary to know, however, in some questions it can lead to some shortcuts, so I thought that I might as well just quickly cover it. So if I have a triangle, it can be any triangle, such as this one here. So if I let this angle be A, and this angle be equal to B, and this angle C, and the angle here that is created when you subtend one side of the triangle BD, then all the exterior angle rule states is that A plus B is equal to D. And now I know this can easily be proved, and I'm not gonna waste time proving it. You can do that at home if you want to. And so yeah, it's really simple to know. Just keep that at the back of your mind when doing some UKMT questions involving triangles. Okay, so the next thing that I would like to talk about is the how to work out the area of a triangle. So whenever I ask someone like what is the area of a triangle, or when I look through a textbook, usually they say, oh, it's just half the base times height. However, there is one important word that you are missing from that sentence, and that is perpendicular height. So if I have a right angle triangle such as this one here, and I asked you to find its area if this side here was 4 and this side here was 8, this side here was 8 and this side here was 4, then you'd say that the area is 8 times 4, so 8 times 4 divided by 2, which is 16, and that would be correct, it is. However, that only works for right angle triangles. So if I gave you another triangle, such as this one here, and that's a bit more irregular, so such as one like this, and I told you that this length here was 4 and this length here was 8, then you couldn't just simply do 8 times 4 divided by 2 to work out the area of the triangle, because as you can see here, this length here, the 8, is not the perpendicular height. The perpendicular height would be from the base here, 4, all the way up to here. Yeah, so this would be the perpendicular height, or h, the height of the triangle. And it's very important that you realize that in some of the questions, that you can't just simply do 4 times 8 divided by 2. It's one mistake that I used to do a lot, but since knowing about this, I no longer do it. So something really simple, and just to follow on, just might as well. There are obviously other ways to work out the area of a triangle. Now these don't usually appear in the junior maths challenge, however they can creep into the last few questions of the intermediate challenge and also into the senior maths challenge, and that is using trigonometry such as the sine and cos. So if you want to work out the area of a triangle, so if I have a triangle such as this one here, and I told you this side was 4 and this side was 6, and I told you that the angle here was 40 degrees, then to work out the area of this triangle, you would do half times A times B times sine C. So if we label this side, so if we label this angle here C, and so the side opposite the angle C would be lowercase c, and so we'll call this angle A, and so this side A, and this angle here B, and so this side here B, then the area of this triangle would be half times 4 times 6 times sine 40, which is obviously equal to 12 sine 40. There's also the cosine rule, which you should also be familiar with, and also the sine rule, but I think that those two seem to come up less often than this formula here. So I'm not going to cover them, but you should be able to find them easily online anyway. Okay, so the next thing that I would like to talk about is the triangle inequality. So if I draw any triangle, such as this one, it works for any triangle you can think of, and if I just quickly label that triangle, so A, B, and C, and so this side will be A, this side will be B, this side will be C, and so what the triangle inequality states is that if I take any two sides, so I can take this side or this, so if I take any two sides of a triangle, so for example in this case I'll take this side here and this side here, and if I add them together, their sum must always be greater than the length of the third side of the triangle. So another way of writing that is, so b plus c is greater than a plus b is greater than c, and a plus c is greater than b. And these inequalities can be proved very easily. So the way to prove it is as follows. So if I take any 2 points, so let's say I have a point here, so let's say I have a point here called A, and I have another point here called B, then do you agree that the shortest line connecting these 2 points is a straight line? So that is the shortest line connecting these 2 points. And so if I then choose another point anywhere on this plane, so I'll just, for example, here, and we call this point C. If I then connect A to B through point C using 2 lines, so if I go from here to here and then to here, you can clearly see that if I got to B via A, from going from A to C and then from C to B, this is not a direct route, and so the length of A and C and B must be greater than the length of A and B. Okay, so now the next thing I would like to talk about, I'm sure that it's been drilled into your head, and that is Pythagoras' theorem. So Pythagoras' theorem states that if you square 2 sides of a triangle and add them together, that sum will give you the square of the third side. Or another way of writing that is a squared plus b squared equals c squared. And the important thing to remember is that this only works for right-angled triangles. For non-right-angled triangles, you have to use the formula and the cosine rule, which is a squared equals b squared plus c squared minus 2bc cos a. And you can clearly see that this is quite similar. This is basically Pythagoras' theorem, but it's been amended by adding minus 2bc cos a on the end of it. So obviously I'm sure you know how to use Pythagoras' theorem, but I'll just quickly go over it. So if I had a triangle such as this one here, and I told you this side here was 3 and this side here was 4, and I asked you to work out the length of length of x, then you would say x squared equal 3 squared plus 4 squared, and so x squared equals 25, and so x is equal to 5. Now that's all good, but one thing that you need to realize when it comes to UKMT questions is that they might ask, to progress further in the question, you might have to realize that a triangle that you have found the sides of, that you have found the length of its sides, is actually right angled, because the ratio of the length of its sides are of a Pythagorean triple. And so what I mean by Pythagorean triple is that it's a right angle where all the sides are of integer length. So for example, the triangle that I just drew was a right angle, and the length of its sides were in the ratio 3, 4 and 5. So that's one Pythagorean triple. The next one is 5, 12 and 13, and the list continues. There are infinitely many. And so one thing you have to realize is that if you work out that a triangle has its sides in the ratio 3, 4, 5, or 5, 12, 13, or any other Pythagorean triple, then you can deduce that that triangle has a right angle opposite the opposite the side with the greatest length. One theorem that you don't learn in school, but it doesn't come up very often, and it definitely won't come up in the junior math challenge, but I have seen it come up in the intermediate challenge as a alternative method, and in the kangaroo and in the Olympiad, and so I thought I might as well just cover it just in case, and that is the angle bisector theorem. So if I have a triangle, it can be any old triangle. So if I have this one here, and so an angle bisector, all it does is that it will cut an angle in half. So if I just use this angle here and I draw the angle bisector, such as this, and so this angle here will be x, and this angle here will also be x. And so if I label this A, label this B, and label this C, and label the point where the angle bisector intersects the opposite side as D, and so if I label this A, B, C, D, what the angle bisector theorem states is that the ratio of these two sides here, so this side here and this side here, is equal to the ratio of this side here and this side here. Or another way of saying that is A to B is equal to C to D, or A divided by B is equal to C divided by D. And in the second half of this question, you will see how particularly this equation here can be manipulated. Okay, so the last thing that I would like to talk about are the medians of a triangle. So what is the median of a triangle? So each triangle has three medians, and you can form one by joining the vertex to the midpoint of the opposite side. So for example, if I take point A, I would join the vertex to the midpoint of the line BC, which would be about here. So this length here would equal this length here, and what a median does is that it will divide the triangle into two equal areas. So this area here is equal to this area here. So what you can then do is you can then draw all three of the medians. So I'll draw the one for B, about there, and I'll draw the one for C as well, so about there. And where they intersect, this point here is called the centroid, just a bit of terminology. So this point here is called the centroid, and if you draw all three medians, you can see that there are 6 triangles made. So one here, one here, one here, one here, one here, and one here. And the area of all these triangles is equal. The centroid is also important because it divides each median into the ratio 1 to 2. So for example, if I just label these, so D, sorry, that's a D, D, E, F, and G, then if we take any median, for example, if we just take the median AF, then the centroid will divide the line such that the ratio of AG to GF is equal to 2 to 1. And this is the this can be said for all of the medians in the triangle as well. So for example, we could say that BG to GD is equal to 2 to 1, ratio 2 to 1, and also that CG to GE has a ratio of 2 to 1. Okay, so the first question asks us to find the area of a quadrilateral. So I'm quickly going to draw the quadrilateral here, and line going up here, and another one like that, and this is a right angle here, and there's also another right angle here. This side is 7, this side is 9, and this side is 3. Okay, so you can see how we have two right angles here, and to solve this problem, what we have to do is we have to connect this vertex here to this vertex here. So if we join them with a straight line, you can see how we now have two right angle triangles, and we can work out this side here by Pythagoras' theorem. So by Pythagoras' theorem, this side here will be 7 squared plus 9 squared, which is 130, and then we're going to have the square root that. So this length here is the square root of 130. So that's a 9, this is look like it. Okay, and now we can then work out this side here, and we can do that by using Pythagoras' theorem again. And so this side here will be equal to the square root of 130 squared minus 3 squared, and then we're going to have to square root that, and that will give you 11. So this side here has a length of 11, and then we can work out the area of this quadrilateral by clearly just doing 7 times 9 divided by 2 plus 3 times 11 divided by 2, which comes out as 48, which is the answer. And that will correspond to letter A. So A is the answer. Okay, so in this question we are asked to find the sum of the marked angles in the diagram. So I've quickly drawn the diagram here, and so to start off with, we have a quadrilateral here. So here, 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 here. And so the sum of the angles in the quadrilateral is 360 degrees. Now, do you also agree that this angle here is equal to this angle here? This angle here is equal to this angle here. And then we can do that for each triangle. So this angle here is equal to this angle here. And then finally, this angle here is equal to this angle. And that is obviously because they are vertically opposite each other. And so we can therefore say that the sum of these marked angles here is 360 degrees also. Okay, so now if we take the 4 triangles, the sum of the angles in all 4 triangles is obviously going to be 4 times 180, which is 720. And so to work out the sum of the originally marked angles, we have to take away the sum of these 4 angles here, from 720, which is 720 minus 360, which is 360. So the sum of the marked angle is 360, which corresponds to B. Okay, so the next question asks us to determine which one of the triangles in the question can be made. So if I just quickly write A, B, C, D, and E, we will go through each option in turn and cross them out if they can't be made. So if we start off with A. So A is clearly an isosceles triangle because it has two sides of them 3 centimeters, and therefore the missing angle should be 25 degrees. However, if we do 110 plus 25 plus 25, we get 160. Now obviously 160 is not equal to 180, which is what they should add up to, and so A cannot be made. So I'm just going to quickly cross off A. Okay, so next we'll look at option B. So B is so the thing is with B, the first thing that we have to do is work out the missing angle, which is 180 minus 130 minus 20, which is 30. Okay, and we can see that the 20-degree angle is opposite the 5 centimeter side, and that the 30-degree angle is opposite the 4 centimeter side. However, this is impossible because the bigger an angle, the bigger the side opposite it is. So the the side opposite the 30-degree angle should be bigger than the side opposite the 20-degree angle, and therefore B cannot be made. Okay, so next we'll consider C. So C is a right angled triangle, and because it's right angled, it should obey Pythagoras' theorem. So if we do Pythagoras' theorem, so if triangle C can be made, 4 squared plus 7 squared should equal 64, which is 8 squared. However, we can clearly see that 4 squared plus 7 squared is equal to 60 plus 49, which is equal to 65. And this is not equal to 64, and so C cannot be made. Okay, so if we then look at D, it's quite hard to prove that D can't be made, and so a good idea, so we're not sure if D can be made or not, so a good idea is to move on to E. Okay, so E has sides 2 centimeters, 3 centimeter, and 6 centimeter. And the triangle inequality states that if you add two sides of a triangle, the sum must always be greater than the length of the third side. And so clearly 2 plus 3 is less than 6. However, for triangle E to be made, 2 plus 3 must be greater than 6, and so E cannot be made either. And so by process of elimination, we can thus deduce that D is the one that can be made. Okay, so this question asks us to find the ratio between QS and SR. So we know this is a right angle here, and because PS bisects the angle QPR, we know that this angle here is X, and this angle here is also X. We are also told that QPR is equal to 60, And so this tells us that this angle here is 30 degrees, and that x is equal to 30, and also that this angle here is equal to 180 minus 90 minus 30, which is 60, and that this obtuse angle here is equal to 120. Okay, so we can clearly see that triangle SPR is isosceles because it has two equal angles of 30 degrees. And by the way, there are actually two ways of solving this, and I'll cover both of them. So this is the first method. So we know that triangle PSR is isosceles, and so PS is equal to SR. And so this side here is equal to that side here. And what we can then say is that, well, clearly the triangle PQS is half an equilateral triangle because it has an angle of 60 and an angle of 30 and an angle of 90. And so we can say that this side here is double this side, and so we can say that PS is equal to 2 times QS. However, SR is equal to PS, so we can say SR is equal to 2 times QS. And what this means is that the ratio is 1 to 2, which corresponds to E. Okay, and so now the other way involves using the angle bisector theorem, which I talked about earlier. So if I just quickly go back to here, that's a bit. Okay, there we go. So we'll start off with this diagram, and so we know that QPR. So we know that the triangle QPS is half an equilateral triangle, and we also know that triangle QPR, so the big triangle, is also half an equilateral triangle, because you could, if you flip the triangle QPR in the side QR, you get the other half of the equilateral triangle. And so that means that the PR is equal to 2 times PQ. Okay, and so what we can then say is that the angle bisector theorem states that PQ divided by PR is equal to QS divided by SR. Okay, and so because the triangle PQR is half an equilateral triangle, and PR is equal to 2 times PQ, PQ divided by PR must be equal to half. Therefore, QS divided by SR is equal to a half, and so the ratio between QS and SR must be 1 to 2, which corresponds to E.